Hey guys, it's Samantha, and this is my online version of my representational teaching moment. My topic's from grade 10 mathematics and it explores trig ratios. I'm just going to bring this up right now because I feel like you can probably all relate to it a little bit. I remember being in 10th grade and learning these exact concepts and participating in the collective groan in the classroom because it was a little bit confusing and a little bit scary, and I guess trig just does not have the best reputation. But I guess that is exactly why I'm here, just trying to figure out a way I'd teach it that will make it a little bit less of a what is even going on moment and a little bit more of a hey, I kind of get this moment. Perfect. So the specific outcome that I'm going to be discussing is develop and apply trigonometric ratios, so sine, cosine, and tangent, to solve problems that involve right triangles. Now, I'm definitely not a teacher yet, so I'm still trying to figure this whole thing out, but today I just want to show you how I think I would approach teaching these trig ratios to 10th graders. And I'm not just going to throw a whole bunch of formulas at them because I think that has been shown time and time again not to work. And that's what happened in me in high school, and it definitely did hurt me a little bit throughout my university math career. So yeah, these are some strategies I think would work and make my students not want to fall asleep halfway through my class. Perfect. So if you guys want to read the indicators for this concept, go ahead. You can pause the video here, but I'm not going to, just in the essence of time. But I will go through kind of my plan for this. We're going to start things off with string modeling, which is not a craft project, but it'll make more sense in a bit. And then we're going to dive into an online trig interactive because let's be so real, everyone was always so excited when we got to pull out the computers and actually get to do some hands-on learning instead of being talked at all class. And then after that, we're going to do an activity. I called it Really Works, which is just a hands-on activity to show the kids that trig really is more than just formulas. And then there's the last thing I'm going to do, which I'm actually so excited about because I remember doing this in my grade 10 year, something similar, and it definitely actually helped me understand what was going on, which is good. Called that one Time to Dance, but that will also make a lot more sense soon. And like I said, I'm still trying to figure out how all of this would work in practice. But by the end of this, I hope that you guys also have some ideas about how you would teach trig or something similar to make it a little bit less terrifying for the students and a little bit more fun. Perfect. So the first strategy I would use to teach trig is string modeling. And before you picture me knitting scarves to the class or something, that's definitely not what it is. What I would do is I would give each student a piece of string that's tied into a circle and then allow them to start kind of manipulating it. So they're going to pick one side that needs to be a right angle, and then they can move the other sides and angles around and kind of see how they react. I think what's super cool about this is as they manipulate the triangle, they'll be able to grasp how everything's staying proportional. So when they change one side, they can see how it impacts the other sides and the other angles. And I think this is very, very important because everything in trig is proportional, and that's why the formulas work. And this is a hands-on activity, so it'll give the students a better sense of which sides are opposite, hypotenuse, and adjacent, instead of just trying to learn these terms based off of the same triangles we always see and the same definitions we always see. So in short, I think that string modeling is just a great way to make these abstract concepts feel a little bit more real and a little bit more understandable. And I also think it is way more approachable to do this than just be expected to work on worksheets all the time. Yeah, I just think it would allow the students to experiment and explore and see how trig works on a more real level. Perfect. So I've included a little video of me doing what I would ask my students to do. And even if you have like a rubber band lying around, a string, anything like that, go ahead and give it a try. You can pause the video here or rewind and watch what I was doing again and just kind of see how it helps your understanding. Perfect. So the next activity I would go through with my students would be this digital approach. So it is a golf game based on trig, and basically the game shows you a right triangle and you get a few side lengths. Then you'll get a question like, if R is here, which side is the opposite and which one is adjacent, and so on. So it's kind of like a puzzle where you just need to figure out how the sides and angles relate using sine, cosine, and tangent. And if you get it right, awesome. You are one step closer to getting the perfect shot. But if you get it wrong, it's not a big deal. The game actually walks you through what you should have done and how to apply SOHCAHTOA, or sine, cosine, and tangent. And this game will help you understand which side is opposite, which one's adjacent, and which one's hypotenuse. So it's really not just about memorizing formulas, but the game shows you how to actually apply them, and step-by-step reinforces those ideas until they stick. So what I think is really great about this approach is that it helps students solidify their understanding of the three sides of the triangle. They're repeatedly asked to answer questions applying SOHCAHTOA, and this way they'll be able to really understand the difference between opposite, adjacent, hypotenuse instead of just memorizing the terms. I also think that those relationships are much clearer just because they do get pretty good, quick feedback. And I know that isn't always the best thing, but I think in a case like this, it can still be super, super helpful. And it also shows them how sine, cosine, and tangent can be applied in real life, like sports. And I think that is super important because it makes it feel less like a formula and more like something that is important and understandable. And just reinforcing that trig isn't just a set of random rules, but is actually useful in things like golf, where the angles and distances really do matter for that perfect swing. So yeah, just instead of staring at equations, students can see how the trig connects to things that they care about, which just makes the whole thing feel a lot more relevant and a lot more fun. So in short, I think that this digital game is just a great way to help students stay engaged and also help them understand the practical uses of trig. And it's interactive and a little bit rewarding and a little bit fun, which I think just makes for a great lesson. Perfect. So this is just a little clip of me playing the game and kind of showing you guys what it has to offer. I'll go through a few good examples here where you can see what happens if you get it right, and then I will go through a few to show you what happens when you're wrong. And feel free to either watch this clip, but I've also attached the game link on this page, so you can also feel free to go check it out yourself and just pause the video here. Perfect. So now that we have explored a variety of ways to understand the relationships between the sides and angles of right triangles, we're going to do an activity that shows us whether or not these ideas actually work in practice. And I called this It Really Works. In this part of the lesson, students will just be given cutouts of various right triangles, each with two known side lengths but no angles. So their task would be to find out which trig ratio, sine, cosine, or tangent, they are going to need to find the missing angle based on the sides they have. So the first thing they're going to be asked to do is to calculate this, like pen and paper, figure out what's going on, use a calculator. And then once they have their final answer there, I would get them to check the angle with a protractor. And in theory, these angles should be exactly the same, which will show them that this formula really does work and it isn't bogus, which I think is super important. I think being able to make that connection and understand that it is correct is very, very important in understanding. By having students calculate the angle and then check the result with a protractor, they can kind of bridge the gap between theory and reality and understand that these ratios do connect to the physical world. I also think this is super, super important because it will build quite a bit of confidence in the concepts, right? Because first of all, they know that they're doing it right. And secondly, they can see how it works, which I think is a very important part of understanding. I also believe it is super beneficial just because it makes it so much less abstract. It makes trig feel way more tangible. And I also think in this, it gets a little bit less scary because there is no pressure on it. It's just a fun activity to be able to kind of test yourself and test your knowledge, which I think is super valuable. Awesome. So I have a video here of myself doing the activity. You can feel free to pause the video here and try it on your own, or you can continue watching and just kind of see how I'm doing it and picture what you could learn from this activity or how it might help your future students understand the concepts a little bit more. Awesome. So for my last activity here, I have something I called It's Time to Dance. Trust me, it's going to be way more fun than that sounds, and I know it does work in a classroom because it definitely worked on me. So, this is just a way for you to remember the core trig ratios. I know we all probably use the mnemonic SOHCAHTOA. So yeah, here's how it works. I will call out one of the trig ratios, sine, cosine, or tangent. So I would say like opposite over hypotenuse or opposite over adjacent, so on. And then from here, there are 3 like dance moves. So for sine, you're just going to jump with your arms up. For tangent, you're going to spin around. And for cosine, you are just going to jump regularly. And this will just help students start to remember the formulas that are used. And what I loved about this activity when I did it, and it definitely did help me learn the concepts a little bit better, is that you're not just sitting there trying to memorize these dry formulas, but you're linking the movement in your head to something, right? It's just an effective way to get these ratios really stuck in your brain, and it's something I still think of when I'm doing them today. And honestly, it's nice to get up and move around, and by the end of this activity, you'll think sine, and then you're going to think of jumping, and then you're going to remember what that ratio was. Obviously, I don't expect anyone to get up and start dancing around the room, but I hope that you can kind of imagine how this would go in the classroom and how it would be helpful. Yeah, so just an overview of these strategies. I think that it is super important when teaching trig and the core ratios for sine, cosine, and tangent. It really isn't enough to just teach the formulas and then expect students to understand them fully. So to ensure that the students do internalize both the concepts and the applications of these ratios, we do need an approach that will take the learning experience from multiple different angles. So that's where these 4 representations kind of came from. the string modeling, the digital approach, the learning through movement, and it really works activity. Each of these methods kind of offer a different insight into how trig ratios work, and when they're combined, they do create a really well-rounded and more like dimensional approach to understanding sine, cosine, and tangent, or SOHCAHTOA. So let's just break down how these representations really do work together to deepen student understanding. For this string modeling, I think that this just really allows students to physically manipulate the string to form that right angle triangle, adjust these angles, and just see how the side lengths change as you do this. I think this just really reveals the proportional nature of trig, and it shows how the sides of the triangle relate to each other based on these angles. So I think this just helps students visualize and internalize how trig ratios work and give them a stronger understanding and foundation to work with later. And then for the digital approach that use that trig game, this just allows students to calculate angles and start to solve these problems regarding trig ratios, but without so much pressure. Because I feel like a lot of the time when I was learning concepts throughout school, it's like you sit, you're supposed to be able to understand based off what's written on the board, maybe learn it at home if you didn't, and then be under the pressure of writing this on an exam. But this just gives students an opportunity to like solidify their understanding, and it also gives them a sense of why trig is practical and why we're learning it, right? Because I feel like a lot of the time it was like, okay, but why do I care? And I think this just kind of gives a student a deeper understanding of why they should care. And then for the It Really Works activity that I had, where we used the triangle cutouts to try both measuring with protractor and then also doing paper to pen calculations, I think that this really does bridge that gap between reality and theory, and just being able to see, first of all, that they really do work. I think this fosters a deeper understanding of the formulas themselves. And then I also truly believe that hands-on problem solving is so important, and that these skills are something that can be used outside of math. And I just think that this confidence that they're learning, because they can try it and they do get that feedback that it is working, and just understanding that that formula will give them the correct answer and that the formula works in real life. And then from the dance activity, I found that this really helped me not only memorize, but like kind of understand what was going on. And it's nice to have an experience that is not just pen on paper all of the time. And I feel like you see that a lot, especially in high school. So just doing this in a more memorable and fun and engaging way, I think will help the students later on, and it will help them to start connecting everything, which I think is a crucial part of this, because if you don't make it memorable, I promise everyone's just going to forget it eventually, right? And then they're going to be relearning all of these things the next year, next semester, whatever it might be. But yeah, I think this just really helps solidify these ideas in the student's brain. Yeah, and so I think when we add all of these different strategies together, the students are offered a way more complete and dynamic experience than they normally would be in a classroom, especially if we're not using manipulatives and we are just sticking to the pen and paper. The string modeling offers this visual understanding of proportions, and then the digital approach really connects trig to real-world applications. And then we had that It Really Works activity, which just shows students that the ratios are not as abstract as they seem, and it makes them so much less scary. And then learning through dance just makes it so much more fun, and you do get that little piece of memorization that will be helpful down the line while still understanding these concepts fully. By using these methods, I just feel like I can ensure that my students were not only memorizing the formulas, but also really understanding how they work, when you would use them, and why they matter. And I definitely believe that this would create a way deeper and way more comprehensive understanding of trig, rather than just trying to force them to learn from me working on the board or just learning it for the test and then forgetting everything. I know that they can see those kind of connections, understand the concepts, and know that it really does work and that it is super important. I feel like a lot of the time trig is kind of taught as just the set of rules, take it as it is, apply it, whatever. But I think that this approach shows that it is more than just a set of rules, and it is a tool they can use, and they can also use the different methods to maybe fully understand other things in other classes, and I think that is very, very important. I just want to thank everybody for listening to this presentation. I know that online presentations can be a little bit daunting and a little bit boring, but I hope you enjoyed mine and kind of see where I'm coming from and can maybe apply some of these strategies in the future.